Okay, we'll look at some of the problems that are in section 9-1, where you have the spinner shown at the right is spun, and we assume that each sector, or the size of each sector, is the same, and then we're going to find the probability of each of the following. In part A, we want to find the probability that the number that we land on the spinner will be a factor of 15. And in part B is finding the probability that the number that we land on will be a multiple of 5. Okay, in this case here, let's start with part A, finding the probability of spinning a number or landing on a number that's a factor of 15. Okay, in this case here, we need to list all the factors of 15. In this case, there's just going to be two numbers that will give us a product of 15. So one pair of factors will be 1 and 15, and the other pair of factors will be 3 and 5. And these are all the factors of 15. Okay, now we need to circle these factors that are also on this spinner. And in this case, there are three numbers that are on this spinner. That's 1, 3, and 5. And there are 8 numbers on this wheel, so 3 of those numbers are factors of 15. So in this case here, the probability of spinning or landing on a number that's a factor of 15 would be 3 over 8. Okay, and then part B is finding the probability of landing on a number that is a multiple of 5. Okay, now let's take a look at our spinner here. You'll see there is only one number that is a multiple of 5, and that's the number 5, because 5 is a multiple of itself. So in this case here, its probability of finding or landing on a number that is a multiple of 5 on that spinner will be 1 out of 8. Because there's only one number that's a multiple of 5, and that's, of course, is 5. Okay, let's take a look at problem number 2. And it says it's supposed to draw from a well-shuffled deck of 52 cards. And here you want to determine the following probabilities. So here we have a well-shuffled deck of 52 playing cards, and we want to find, let's say in this case here, the probability of drawing a 10. Well, in a deck of 52 playing cards, there are 4 10s in that deck. The 10 of hearts, 10 of diamonds, 10 of clubs, and 10 of spades. So there are 4 10s in that 4 out of 52. That's the probability of drawing a 10. Now, let's reduce that to 1 over 13. That's the probability of drawing a 10. The next problem is, what's the probability of drawing a 6 or a jack? Now the key word in this case is or. So that means we're going to have to find the probability of drawing a 6, and we need to know what the probability is of drawing a jack. Well, the probability of drawing a 6, that means that there are 4 6s in that deck, so it'll be 4 out of 52, which is of course 1 over 13. And likewise, there are 4 jacks in a deck of 52 cards, so that's also 4 over 52, which is also 1 out of 13, reduced in simplest form. So now, the probability of drawing a 6 or a jack will simply just be adding the two probabilities together. The probability of drawing a 6 will be 1 out of 13, plus the probability of drawing a jack is also 1 out of 13. Well, if you add 1/13 to 1/13, you're going to get 2 over 13. That represents the probability of drawing a 6 or a jack. Alright, the next problem is, what's the probability of drawing a spade? Okay, in a deck of 52 cards, 13 of those cards are spades, from ace all the way to, well, from 2 all the way to ace. There are 13 cards that are spades. So the probability of drawing a spade would simply be 13 out of 52. And if we reduce that, it'll be 1/4. Alright, the next problem is what's the probability of drawing a red card? In this case here, the diamonds and the hearts are red cards. There are 13 diamonds, 13 hearts. So in this case here, the probability of drawing a red card would be 26 out of 52, which is simply going to be 1/2. Because if you look at it, half the deck of 52 cards are red cards. You have 13 diamonds, 13 hearts, for a total of 26 red cards. So that's why it's 26 over 52, which is reduced to 1/2. And then finally, what is the probability of drawing a red jack? Well, there's only 2 cards that are red jacks. We know there are 4 jacks, but 2 of them are red. The jack of hearts and the jack of diamonds. So the probability of drawing a red jack, in this case, would be 2 out of 52, which is equivalent to 1 over 26. Okay. All right, let's take a look at some more probability problems, like this one right here, number 3. A marble is selected at random from a jar containing 5 red marbles, 2 yellow marbles, and 3 green marbles. What is the probability that A, the marble is red, B, the marble is not yellow, C, the marble is either red or green, and D, the marble is neither red nor green? All right, let's start with the probability that the marble is red. Now, there are 5 red marbles in this problem, because it says so here, out of 10 total. So the probability that the marble is red, in this case, will be 5 out of 10. Because there are 5 red marbles out of a total of 10, so it'll be 5/10. And if we reduce that, it will be 1/2. The next one is what's the probability that the marble is not yellow? Well, in this case here, if it's not yellow, then that means it's got to be either red or green. And we can look at the probability of a red marble, which is, of course, 5 out of 10, and then the green marble is 3 out of 10. So if you add 5 and 3 together, you're going to get 8. So the probability that the marble is not yellow will have to be 8 out of 10. And if you reduce that, it'll be 4/5. And then the next one was the probability that the marble is red or green. Well, we just looked at that. You have 5 red marbles and 3 green marbles. That's a total of 8, which again will be 8 out of 10, or 4/5. Now these two problems are right here are similar. Those are complementary events. And then the last one, what is the probability that the marble is neither red nor green? Well, it's neither red nor green, then it has to be yellow. And there are only 2 yellow marbles, so that means this probability will have to be 2 out of 10, or 1/5.